afternoon, everybody. Today, let me welcome you for the session of LTI systems representations in time domain. This is lecture 7, right? All my previous lecturing sessions are all based on this LTI system only, linear time invariant system only. Now, this is coming under VTU for 4th semester ECE students under module 2. This can also be studied by anybody, any disciplines, or any other than engineering also, whoever interested in signal processing domain, right? Maybe MTech signal processing or PhD signal processing, they can use, right? These are all the sessions of signal systems, right? Definitely today's world is signals only based on, right, audio processing, video processing, multi-audio, multimedia. This is what today's world. And definitely we need this, right? This domain, this signal processing. Now, in my previous sessions, right, we discussed LTI systems, LTI linear time invariant systems only, where X of n and H of n are input and impulse functions, and Y of n is the output of LTI systems. X of n and Y of n, how to represent in time domain, right? We have shown last classes, and how to deal this X of n and Y of n in terms of shifted impulses we shown through derivations, and in the end, right, if you apply input as shifted impulses, and you will get the output also in terms of shifted impulses, which is nothing but convolution sum, right? Then now we dealt 4, 5, 6 properties, and we dealt the problems also. Previous sessions. In the previous sessions problems, we have taken one complex exponential X of n and the other as H of n, Y of n, H of n as normal simple step functions, and we showed. Today we will see, right, in real time, right, you will be having not only step functions, right, step and impulse functions you will not have. You will always have, if you have both exponential, both the input, for example, X of n is also exponential functions. Let's say through an example, beta to the power n and u of n, and H of n is also exponential. Second one is also exponential. Then how the output? Output you will get exponential to exponentials, which way we will see now, right? Actually, in real-time processing, when you are doing projects, today's world, where text or audio or video or multi-audio or video processing today's, right, where and all, you will not get only X of n, right, as exponential, or only will not have, right, the step function only, or a simple functions like impulse function only. No, you are having both exponential only, right? This type of complex signal processing only you are having, right, to do projects and all. That's why this is the best example, right? What is that? When both are exponential, let us see how to do this convolution sum. Find output through example. Find output Y of n for the following signals using convolution sum. Y of n is equal to, let's see, is giving beta to the power n into u of n. This is one exponential function, and into convolution sum alpha n into u of n, where mod beta is less than 1. What's the meaning? Mod beta is less than 1 means beta greater than 0, less than 1, both sides. This side also greater than minus 1, less than 0. Both the sides it is less than 1 and minus 1. Similarly, right, x to n is giving. X to n is again, that is also exponential. This is also exponential. One exponential, the second exponential, right? Alpha to the power n into of n, where mod alpha is less than 1. Here also, alpha value, what is telling? Alpha value is less than 1, greater than 0, right? And same as this side also, mod alpha. Maybe minus 1 it is greater than, and it is less than 0. That way, right? Then you will get, let us say, how to solve this problem. Then same solution is very simple. First write let x1n, first signal as this exponential first one, beta less than 1. Second signal as x2n. Then plot that. We know this, right? Y of n, convolution sum output is equal to, formula is there, x1n into x2n, convolutions of, standard formula is there, summations, k k is equal to minus infinity plus infinity x1k, x2 of n minus k. That is the standard form. We have used last sessions also. Now, plot x1n and x2n. Plot first two diagrams. Right, x1n versus n, x2n versus 1n. What is the similarity? This time we will get both are exponentially decreasing. Instead of last previous sessions it is a step. Here both are exponentially decreasing. Exponential function only. And it is step only. Right sided only. Then what is the meaning? First one, let me assume let beta as for the first one x1 versus 1n. When you plot that you will get exponentially decreasing like this. That is giving mod beta less than greater than 0 less than 1. Right? Let's say this is an exponential input. Let us say beta is equal to 0.9. Let me consider. Beta is equal to 0.9. It is less than 1 now. Let me write 0.9. Then what happens? Plot this. At 0, x1 0 is equal to beta to the power 0.9 to the power 0 into u of 0. U of 0 is 1. 0.9 to the power 0 is nothing but 1. At 0 you will get 1. Both the case, maybe here also you will get 1. Then when n is equal to 1, x1 n 1 is equal to 0.9 to the power 1 into u of 1. U of 1 is 1. Right side. Therefore 0.9 to the power 1 is 0.9. At 1 you will get 0.9. At 2 you will get 0.81. Like that it is decreasing, you will get exponentially decreasing first one. Beta is 0.9. Similarly do for second one. That is also exponential. x2n is equal to alpha to the power n into u of n is the expression. But consider alpha as alpha value is less than 1 greater than 0 both sides. Right. Now let me say 0.8 alpha is equal. Then what will happen? Negative side you will not get because u of n is giving. U of n means u of minus n is 0. 0 into negative side is no, that gets 0. That's why only right side sequence you will get both exponential. Right. Now alpha is equal to 0.8. Don't consider alpha and beta equal. Right. Consider alpha as some value 0.7 or 0.6. Beta as some value. For example 0.8 I will take. Now at 0 x2 0 is equal to 0.8 to the power 0 is 1. At 0 it is 1. Both are same. At 1 alpha 1 0.8 to the power 1 is 0.8 and u of 1 is 1. 0.64 second one. Like that it is decreasing. You will get first two graphs. What is that? x1 versus n, x2 n versus n. Both are exponentially decreasing. What is the similarity in both two? Both are same. Both are exponentially decreasing only. But one is at 0 there is no change. At 1 it is 0.9, at 1 it is 0.8. At 2 it is just decreasing. This is a big fellow, this is small fellow. That's all. But both are same fellow. Both are exponential only. Now the third and fourth graph you know it. First four graphs you have to write. First two is same. Next first one as it is you write x of k versus k you write. Instead of x of n versus n, no change. You write for the right side actually. What is that? X of k versus k. Same at 0 your expression becomes beta to the power n instead beta to the power k. U of k is 1. Then at 0 is 1. At 1 is 0.9, 0.81. Exactly same. Only change is x of k versus k. Fourth graph is exactly a replica of the previous graph, second one. I told you last class also. Why? Because you see this should be the mirror image of that, n minus k, x2 of n minus k. That is why take second one, write the mirror image. Then now we will get like this. Now see, x2 of k means n minus k, which is nothing but alpha to the power n minus k. Alpha to the power n is there now. Alpha to the power n, that is n minus k. That's all. Then what you will get? You will get exactly reverse. At 0 it is 1. At 1 minus 1 it is 0.8, 0.64 like this decreasing. 4 graphs over. Then over first thing is writing 4 graphs. Writing first 4 graphs x1 versus 1, x2 versus n, then x1 x of k versus k, then x2 of x1k versus k, x2 k versus k. This is just mirror image. K is equal to n. K value varies from where to where? 0 to n. See this? K values n less than 0 nothing. N greater than 0, k values varies from see this 0 to n. Like that you will get output when you do these two 0 to n k values you will get. Each time this gets shifted this side, this into this. Between 0 to n you will get the values. Now with this we can do the maths now. When n less than 0, see the first two graphs. N less than 0, since u of n is there now, right sided only. Therefore n less than 0, x1k into x2k value is 0. y of n is equal to 0 for n less than 0. Nothing exists for n less than 0. Only you will get for n greater than or equal to 0, this shifts, you will get answers. Now, that's what I am making. N greater than or equal to 0. Your y of n varies from, I told you, k varies from 0 to n. This is what I said. K varies from 0 to n. This each time shifts this side. Right, 0 to n you will get the answer. Now that is why I am writing summations. K is equal to 0 to n, x1k into x2 of n minus k. Then substitute k is equal to 0 to n. Beta to the power, what is x1k? x1k is nothing but beta to the power k into 1, because this side. Right. Now, beta to the power k into 1. What is x2 of n minus k? x2 of n minus k is alpha to the power n minus k, this side. Right, reduce it. Now, therefore alpha to the power n minus k. Then afterwards do the math simplifications. Split this, summations k is equal to 0 to n, beta to the power k as it is, alpha to the power n minus k as alpha to the power n into alpha to the power minus k you write. Alpha to the power n you write outside. Now write this outside, the rest write inside because formula is there. Summations k is equal to 0 to n, beta to the power k by alpha to the power minus k come down, right, bring it down, right, beta by alpha to the power k like you can write. Now this is also alpha to the power minus k only, right, this I will write inside. Now this whole term is nothing but alpha, let us say. Then there is a finite sum formula already we have used there, stand. What is that? Say finite sum this is, k is summations k is equal to 0 to n, finite sum, k is equal to 0 to n minus 1 let us say, alpha to the power k, then there is a standard formula, 1 minus alpha to the power next value of n minus 1 is n. Here also next value of n is n plus 1 you have to write. By 1 minus alpha. Alpha not equal to 1. Why? Alpha should not be equal to 1. If it is equal to 1, 1 minus 1 is 0. This by 0 is infinity. Therefore, it should not be equal to 1. Right? Then, this is the formula. This like this. Then you have to make use of this and you have to write. Alpha is equal to 1. If suppose if this is equal to 1, 1 minus 1 is 0 now. Then you have to use the L'Hospital rule. Then you will get this is equal to n only you will get. How I am getting, I have shown here also. Right, there I will see later. This I have shown here, we will see later. Now, right now remember this. When this is equal to this is the formula. Is equal to 1, this is the formula. Now let me apply this formula first one here. Alpha to the power n, summation k is equal to 0 to n, beta by alpha to the power k is there. Now apply that formula, y of n is equal to alpha to the power n into, what is alpha? Alpha is beta by alpha. 1 minus beta by alpha to the power n plus 1. This is n plus 1. N is there now, n plus 1. Beta by alpha is alpha. Alpha to the power n means n plus 1 here. Now see, beta by alpha to the power n plus 1. By 1 minus alpha is beta by alpha. When n not equal to beta. Because here, n not should be equal to beta. If it is equal to beta, both are, see, I have assumed beta has 0.9, beta alpha has 0.8. If both are 0.9, then 1 minus 1 is 0. This becomes something into 0 is infinity. Will not get stable output. Therefore, beta is different, alpha is different. Then only this formula. Right? When both are equal, for example, then this gives more flexibility. Right? You can go up to 0 to 9, 0 to 1, alpha. Here also 0 to minus 1. Beta also 0 to 8, minus 9, 0 to plus 9. That is where this is very, very useful in doing the projects. Right? In real-time processing. Now, when both alpha is equal to beta, then what will happen? You should go for L'Hospital rules. What is that the rule says? That rule says actually, then when both are zeros and zeros if you get, you have to use this rule to simplify actually. That says, this rule says this maths actually. You have to differentiate numerator first, numerator separately, denominator separately, till you get finite value. Here in this case, when alpha is equal to beta, you need not have to worry. Simple way you can do. Alpha to the power n into n plus 1 you will get. However, see this, take this equation 1. Alpha and beta is equal to 1, suppose. Beta is 0.9, alpha is 0.9, let us assume. Then both are cancels, 1 to the power k will get. Then what will happen? Y of n is equal to alpha to the power n, k is equal to 0 to n. When both are equal, 1 to the power k you will get. That is equal to 1 to the power k is equal to n plus 1 you will get this. However, we will see here. I have shown here. For example, take that when alpha is equal to beta from equation 1, y of n is equal to alpha to the power n, summations k is equal to 0 to n, beta by alpha to the power k. Let's say now alpha is 0.9, beta is 0.9 in this case. What will happen? alpha to the power n, k is equal to, let us say ns3. Let me say this ns3. N is equal to 3. 1 to the power k. Beta by alpha 0.9 gets cancelled. 1 to the power k is equal to, expand this, when k0, 1 power 0. When k1, 1 power 1. When k2, 1 power 2. When k3, 1 power 3. Then this whole thing is equal to 4. Now see, when you give 3, you will get 4. What's the meaning? Y of n is equal to alpha to the power n into 3 plus 1 is equal to 4. What is n? N, that is also nothing but n plus 1. Therefore, y of n is equal to alpha to the power n into n plus 1. This is what I am substituting here. See now? This is what, when alpha is not equal to b, using LRT rule, if it is complex, then you will get alpha to the power n into n plus 1. Now, this is what I have written actually. Now see, output is equal to, is also in terms of exponential. Output is equal to, when both inputs of the LTI systems are given as exponential, you will get output in exponential only. Alpha to the power n in this way. 1 minus beta by alpha to the power n plus 1 by 1 minus beta by alpha when not equal to. Right. When is equal to, you will get this. This is also exponential. Now, as an engineers, right, you cannot stop here. You have to write everything in terms of u of n, because he is asking in terms of u of n only. Engineer like, actually, for example, he is asking the expressions in terms of exponential in terms of u of n only. For example, here, see this, in the expressions he is giving u of n, exponential with respect to what is that? U of n, exponential with respect to the step only. Then you have to write also in that way only. Then what you have to do? Y of n is equal to alpha to the power n 1 minus beta by alpha to the power n plus 1 by 1 minus beta by alpha into u of n. Alpha not equal to beta. Alpha is equal to beta. Just write in terms of u of n. You will get full. You will not miss anything. Now this is how we can get complex processing actually. This is how only, what is the meaning? This is how we can get exponential output when both x of n and h of n are exponential. Both are exponential in the LTI. Your output is also in the form of exponential. That is this. But in this is what actually exists in our processing. Today's whatever we are using, this is what actually the inputs. Not your step only, not your impulse only. Right? That's why it's very, very useful to design and to see effectively today's projects, today's processing audio, video, or multi-audio video. You see now, today you can do conferencing, multi-audio, multimedia, everything. Right? This is where this analysis helps a lot. Right? I hope I am very clear. Right? Next class, if right, let me do the second half of the module, which is exactly same LTI systems. Right? Convolutions, integral instead of discrete. Right? It is continuous. Convolution sum instead, do convolutions integrations. It is very, very easy, interesting. Same thing only will repeat. Right? Till that, thank you. Right? Bye.